Okay, continuing on with compensating programs, break out your calculators for this unit so we can have to be doing some calculations. And so calculating compensated significant points can be a challenge. By completing this unit, you'll appreciate what MasterCam does for the programming process. And so we're not going to be dealing with MasterCam in this course, but you'll get an appreciation for sure. In terms of some history, it was in finding a better way to solve this kind of math that MasterCam software was born. So you'll have an appreciation getting a chance to a little bit do this by hand. So what about coordinate shifts for uncompensated programs? To profile mills this shape using a cutter path program, each significant point must be calculated as a distance off the geometry. So now we're seeing a CAD diagram that shows the geometry. And so this is what we would be using as we're starting to evaluate how we're going to do the milling for this type of a part. Points A and I are simple. They're program coordinates. A prime and I prime are the radius distance away from the geometry at 90 degrees. To write the cutter center line, the blue line, you'll need an X and Y location for each point starting from A prime and ending at point I prime. These are the offset points caused by the cutter radius distance off the part geometry. And so now we're seeing these examples of how that would be seen with a diagram here to think about a sample tools path sketch. So to find the point B prime based on B, we can be looking at the figure here and how with the ability of the rotating and translational way of doing this, we're going to have to be doing this kind of a calculation. And so you're going to have to know trigonometry and geometry to be working that out by hand. Okay, for writing an arc command, don't put your calculator quite away yet, because we have to be thinking about this for arcs. The next toolpath challenge is calculating arc commands. Depending on the part shape, they can be simple or require a bit of computation. So for arc parameters, writing an arc command is not unlike drawing an arc with a compass. You must have 5 parameters. The endpoint, the radius, the center point, the direction, and the start point. So those are all things that need to be known. 3 command methods. There are 3 different ways you can program an arc. Each begins knowing by default the start point. Since it's a current cutter's position, it's automatically known. Then by identifying other key information, more parameters are automatically known as well. So for example, if the center point is identical as a coordinate, then the radius is automatically the distance from the start to the center. Each of these 3 methods supplies a combination of key parameters, such as the others are automatically known. One command identifies the center of the arc, the endpoint, and the curvature. Another identifies the radius distance, curvature, and endpoint. These 2 are the ones we'll study in the text: the radius arc command and the center ID command. A third method not discussed in the text is the polar method, where the key parameters are the radius, degree of arc, and which direction, either clockwise or counterclockwise. So just finishing up here for writing compensation programs. Now we don't need our calculator for this. After the last 2 units, you have an appreciation for letting the computer do the calculations using cutter comp commands. For compensated programs, we use the part path geometry, not the calculation tool path. So cutter left G41 or right G42. This is something to think about, and we'll get a chance to see a figure in a second that might help you to see this. The first item to define after writing the part path coordinate is to which side of the geometry line is the cutter to go. Think of it this way: if you were moving along a fence, which side of the fence are you on? You, that is the tool, are either to the right or left of the fence, that is the workpiece, looking in the direction you were walking. Here's what it would look like, and you can be seeing that you're either on the the cutter left or the cutter right. And so this would be G41, this would be G42. And so this would be helpful for you to be seeing how you're going to be doing this for a cutting scenario. In addition to the compensation code G41, cutter left, or G42, cutter right, you'll need to write a ramp-on path that brings the cutter to the work in such a way to begin compensating and not leave marks where it begins cutting. You'll also need to add a code that refers to the tool radius, compensation memory for distance offset from the geometry. Then, with your program properly written, watch the magic happen as the cutter traces around the work shape. So to conclude, what we have for this module, after working the problems of hand program compilation, you can see what a time and mass saver CAM software can be. And so keep that in mind. It does it all for your based on a part drawing. So you can see the importance of the drawing for actually this manufacturing process. Still, you won't want to finish your training unable to write programs by hand. So, okay, we'll end it there. This is the end for this module. Thank you very much.